Imagine standing near a roaring campfire on a cold night. As you step closer to the flames, the heat against your skin intensifies. It is easy to apply that same logic to our planet. We often assume that northern hemisphere summers happen because Earth physically moves closer to the sun. While that mental model is logical, it is actually a total contradiction of how our solar system functions. Earth's path around the sun is an ellipse, a slightly lopsided oval rather than a perfect circle. This means our distance from the sun does change as we orbit. This data reveals a surprise. At perihelion, Earth reaches its closest point to the sun, 91.4 million miles away, around January 4th. 6 months later, at aphelion, Earth is furthest from the sun, 94.5 million miles away. That happens around July 5th. While 3 million miles sounds significant, it is a tiny fraction of the total distance. Compared to the vastness of space, this change is too small to drive our global weather. If distance were the cause, we wouldn't have freezing January snow in the northern hemisphere at the exact moment we are closest to the sun. The real driver of the seasons is geometry. Earth spins on an axis, an imaginary pole running through the center, but that pole doesn't stand up straight. To see why the lean matters, imagine a flashlight. If the beam hits a surface head-on, the light is packed into a tight, bright circle. But if the beam hits a tilted surface, that same amount of energy gets stretched into a weaker, faded oval. In June, Earth's tilt angles the North Pole toward the sun for summer, while the South Pole is tilted away into winter. 6 months later, the hemispheres trade places. The North Pole leans away, while the South Pole faces the direct heat. Our seasons are simply the result of which hemisphere is currently leaning into the sun's most direct energy. This raises a question. Why is the planet permanently leaning sideways in the first place? Billions of years ago, a young Earth likely rotated with its axis pointing straight up and down. That changed when a Mars-sized object named Theia collided with our world. The force of that collision knocked Earth off its vertical axis, creating the permanent 23.5-degree lean we see today. The impact also blasted a cloud of rock and debris into orbit, which eventually clumped together to form our moon. Without this collision, Earth would have no tilt, and we would live on a planet with no changing seasons at all. This ancient planetary crash dictates the clothes we wear and the activities we enjoy throughout the year. Every January snowball fight, every spring bloom, and every hot beach day is the legacy of the Theia collision. The changing weather outside your window exists because of a massive cosmic accident that happened billions of years ago. Thanks for exploring the universe with Science Senorita. Keep wondering, and I'll see you in the next one.